Hi, good morning, grade 7. This is Ms. Ruqayya, and now I will revise with you the topics that we have covered this quarter. And I will start by listing down the objectives that we have covered from the beginning of the quarter. So we start by modeling the states of matter, particles, motions, and arrangement, how the particles in each state of matter were arranged and how the distance between them is and how they behave, which depend on that. Then we relate the structure of these particles, how they are arranged to their properties. We relate the structure of matter to their properties. Then we identify the type of energy that each particle have, kinetic, potential, and the sum of them thermal. Then we relate the particles' behavior and structure to their energies. Depend on the energy they have, the matter itself behave. Then we name the processes involved in changing the state of matter from liquid to gas, from gas to liquid, liquid to solid, what the process is called, and so on. Relate the change in state of matter to the change in temperature. What the effect of temperature changing in temperatures in changing the state of matter. And then we relate the change in the state of matter also to the change in pressure. Do the change in pressure make or cause changing in the state of matter, and how? Then we relate the evaporation rate to the air pressure. Is the evaporation rate on land the same as on high altitudes and mountains? Then we classify elements to metals and non-metals. Then we relate the molecular structure of either the metals or non-metals to their bulk properties. Are they shiny or dull, brittle or malleable, conduct electricity or no? All this is related to how these elements are, the particles, how they are arranged. And then we classify also the compounds to ionic and covalent. Sorry for the background. Then classify more the covalent into polar and non-polar, which have charges or no, they will be attracted to each other, the molecules, or no, which will differ in dissolving later. Relate the molecular structure of compounds to their bulk properties. So we have mentioned that before, okay? Neglect that one. And identify the relationship between two variables and their graphs. What are the two variables? What are the relationship between any two variables? Can you remember? We'll say this in details later. Okay, let's start by the first objective, which is the model the state of matter particles and their motion. Okay, we'll start here. If we can see, like, we will only focus on neon, let's say. Neon, when it is solid, how the particles are close to each other, have fixed shape and volume, right? And do they move? What can you see? Yeah, they move. So if I ask you true or false, solid particles do not move. Absolutely false, because they are moving, but they are not changing their locations from place to place. They are only vibrating in place. And this gives it its properties. So this is the molecular structure, which they are tightly arranged close to each other. The distance between them are very close. The attraction force between the particles is very high. That's why they have a definite volume and shape. Wherever you put them in the container, they still have their shape. The rock, you put it on the table as you are put it inside the container. Inside the container, its shape will be the same. Its volume will be the same. Okay, this the solid. Let's go to liquid. How you can see them? What about their distance? Exactly. The distance are a little bit farther from each other relative to the solid. At the same time, can you see they are passing above each other? Yani they are vibrating at the same time they are moving are moving past each other, flowing above each other in layers. That give it what property? Do the liquids flow? Do they flow from do they flow from one place to another? Liquids? Exactly, they flow from one place to another. This is because the particles are doing what? Vibrating in place, plus they are sliding above each other, okay? You can see those two particles that they got, like those three, that they got enough energy. When they got enough energy, they escape from the others and they are moving back, moving up. When they lose the energy, they come back down again. What this process called? When they gain more energy, so they become stronger, moving more and more, so they can escape from the others. What this called? Perfect, evaporation. Evaporation, where they go up and down. Okay, it's not our point now, but because let's say the simulation drive us to it. So the liquid, what bulk properties, like the bulk amount of liquids, how they behave. They flow, they don't have a definite shape, they take the shape of the container, right? Because what happened to the molecular structure? Right, they are not tightly packed to each other. The attraction force between the particles are relatively weak. The distance between them is relatively, we are comparing it between liquid and gas, between solid and gas, is like a medium, or distance between them is bigger than that of solid. So they slide past each other and they flow. Okay, let's go to gas. As you can see, there is a large space between the particles, right? They are moving in all directions. That's why the gas is what? Compressible. The gas is compressible. You can compress this container, the same number of particles, the same amount of gas, you can put it in this container. If we see that this one is like a balloon, you can squeeze it to half the size and it will also fit. It will not blow up. Why? Because here the air particles or the gas particles are far away from each other, so you can compress them in smaller space. Like here, if I wanted to make it like gas, okay, here I'm skipping something, but just I wanted to show you something. Okay, so I'll keep heating it till it become gas. Okay, now can you see here the gas is all over the container, right? See, if I squeeze them or compress them in smaller volume, still it fit. Why? Because there is a very large spaces between them, even more and more. Okay, so the gas are compressible. Why? Because there is a large space between the particles. Whatever what happened now, you explain it later.
Okay, so back to the modeling part. This how you draw or model the different state of matter. As we said, using the fit simulation, they are close to each other, and you represent the energy and motion by those lines. Solid have less motion than liquid, and liquid less than solid. The distance between the gas particles are more than liquid, more than solid. Those lines represent two things: the motion and the kinetic energy. Okay, so let's go here to the types of energy that the particles have. The particles have three kinds of energy, mainly what we need to highlight: kinetic energy, and potential energy, and thermal energy we will mentioned just a moment. Now the kinetic energy, as for any living organism, when we say it have a kinetic energy, it is the energy of motion. When I say Ali have a high kinetic energy, that means that he is moving a lot. Same here, particles, when I say that the particles have high kinetic energy, this means that they have a high speed, or their motion is high. And I represent the motion, which is indication for the kinetic energy, by those lines. The potential energy, as it is the energy between two objects that have a distance and attraction between them. Here the two objects in our case are the particles. Okay, as the distance between the particles increase, the potential energy increase. Okay, so the potential energy depends on the distance between the particles and the attraction between them. Based on this, what do you think? Which kind of particle or of matter that have the highest potential energy? I said that the potential energy depends on the distance. As the distance between the particles increase, the potential energy increase. So which one of them have the highest potential energy? Excellent, the gas, as they have the biggest distance. So the potential energy have the gas have potential energy higher than liquid and higher than solid. What about the kinetic energy? Same. Isn't it the gas particle moving more than the liquid and solid? So they have more kinetic energy. So also the gas has more kinetic energy than liquid, more than solid. Okay, but what the third type of energy? Thermal energy. Thermal energy, it is the sum of kinetic energy and potential energy. This is the thermal energy. Okay, and here, before I go to what the thermal energy depends on, there is a very important point. Here, when I say temperature is what? Temperature measures the average kinetic energy of particles. Temperature measures the average kinetic energy of particles. So when I say temperature is thermal energy, false. When I say temperature is heat, false. Temperature is what? Is the average. Measure the average of the kinetic energy of all the particles. If the average of the motion and the energy of the particles are high, so the kinetic energy is high. If the average of the all particles are low, so the temperature will be low. Okay, and the temperature is measured, like as we said, in degrees Celsius, in degree Fahrenheit, or in Kelvin. Okay, thermal energy. Back to the thermal energy. As we said that the thermal energy is the sum of kinetic energy and potential energy. Kinetic energy represents the motion, potential energy represents the distance and the attraction between the particles, which differ from one state of matter to another, right? So if I wanted to say what the factors affect the thermal energy of matter, what do you think? The motion of the particles, the state of matter, the number of particles and mass. What do you mean? If I have like a cup of tea, I wanted to prepare a cup of tea, or I will boil, let's say, water for boiling pasta or something. Here I will put like about 1 cup of water. Here I will put about 4 cups of water, right? But which one of them will take? Both of them are water. Both of them are liquid, right? Which one of them will have more will take more heat to be like, let's say, to boil? Which one will need more thermal energy and will take more time? Is it the pot or the cup? Sure, the pot. It's not because of the state of matter, because both of them are liquid. It's not about the motion, because we are having like the same source of heat. And it's also water. It's not one of them is water and the other, let's say, oil. So a different kind of particles, their mass or the size of the particle. No, both of them are the same thing. So it's not the particles in motion, it's not about the state of matter in our case when we are asking about the cup of pot, but it's about the mass and the number of particles, which actually they are the same thing. As you have more number of particles, this means when you have a more mass, this means that you have more number of particles, which makes sense here. So the thermal energy depends on the particles' motion, depends on the state of matter, number of particles, and mass.
Back here, now we will name the processes involved in changing state of matter, and we will relate the change in temperature to the changing state of matter. Now I have solid. How many factors can I use to change the state of matter? Temperature and what? And pressure. Temperature and pressure. Okay? But now, if I heat this solid substance, which is neon in our case, solid will be what? Liquid. If I keep heating it, it will become, as the particles are moving away farther apart from each other, more and more become gas. Okay. Let's go back again. Now, from solid to liquid is what? What the process called? Exactly, melting. And from liquid to gas, condensation. The back. From gas to liquid, what happened to the motion? They become less. What happened to the energy? Less. So they become liquid. And from liquid, now I want to show you, if I keep like cooling them, they are almost what? Gas, solid, exactly. You can, because here you can see that the particles almost stop, which is this one, 0 Kelvin, by the way. We cannot do it at real life. So it have to be like a bit, at least vibrating. Okay, this is what happened in real life, that the solid state, they are vibrate. So from solid to liquid, melting, liquid to gas, boiling, gas to liquid, gas to liquid, condensation, liquid to solid, freezing. Okay, there is another way where you can change the solid to gas, the solid to gas, by like getting some pressure and heating. You will be able to get from solid to gas directly. From solid to gas directly without being liquid in between, this called what? Sublimation. Sublimation from solid to liquid directly. Okay, from gas to solid directly without being liquid in between, deposition. Okay, now you'll find that the gas, by doing what? By cooling and at certain temperature, see, it will be like a solid direct without being liquid in between. It's not slide above each other. From gas to liquid directly, this is called deposition. Okay, so now what we did, we have covered the particles arrangement and motion and their state of matter. and relate them to the properties of state of matter. We identify the type of energies and how this affect the behavior of the substance, and name the process involved in changing the state of matter, and how temperature affects the change in state of matter. Now let's see pressure. Okay, so we will reset this. And now pressure, I can change the pressure by how many factors? Actually 3. How many things you can see? This pressure gauge show you the pressure, okay? I wanted to show you how I can change the state of matter, sorry, the pressure by different ways, but just let me make it gas so it's more obvious for you. I'll keep heating it till it becomes gas. Okay, now it gain enough thermal energy and become now in gas state of matter. Okay. Now, see the pressure from the beginning, it was 0. By heating, what happened to the pressure increase? Now it's gas, right? Let's heat it more. I want you to focus about the numbers here. How many atmosphere? And we said that atmosphere, which is abbreviation ATM, is the unit of pressure. See, by heating, can you see the numbers? What happened to the pressure? Increasing. So you can increase the pressure by increasing the temperature. Why? Can you remember the cause and effect, the sequence of thinking and reasoning? What we said before. As you are heating them, what you are doing, you are transferring thermal energy to the particles. As the thermal energy of particles increase, their motion increase. When their motion increase, they collide with each other more or less. Excellent, more. As they collide more, the pressure increase, right? So let's decrease that. So I increase the pressure, the collision, which means the pressure by heating. So I will do something else. I'll just cool it a bit so you don't say that the effect was the temperature. I'll try decreasing the pressure by decreasing the heat and let the particles lose a bit of thermal energy. So the pressure, as you can see, decrease. Okay. Now I will do something else. I will change the volume. See, I will change the volume, the space these particles have. So I will just decrease the volume. When I decrease, make it smaller, decrease the volume. See the pressure? The pressure was very high till it like push the lid away. Let's do it again. This is gas, okay? See here the gauge here, okay? Keep an eye on the atmosphere, on the pressure. I'm just decreasing the volume. See? I didn't change the temperature. The temperature is 97 Kelvin, or let's do it at degrees Celsius, negative 176 degrees Celsius. This is the neon. See? The pressure is increasing, become more by decreasing the volume. So this is the second way. This is the second way. First, I have heated. I heat the particles, so they gain more thermal energy, so they collide with each other more, so the pressure increase. Now, also I can increase the collision. I can let them collide with each other more, so the pressure increase, but not by heating, by decreasing the volume. Okay, what else? Let's have it in a gas also again. First, because it's more clear in gas. Okay, now once it is gas, let's wait till the pressure is almost constant. Okay, it's about from 23 to 25 maximum. Okay, now what's my aim? To increase pressure. طب how I increase pressure? By make the particles collide more. طب how I can let them collide more? I can now give them more particles, more number of particles. See? Can you see here? The particles are coming out of this pump. More number of particles. When I give more number of particles in the same space, in the same container, do not make them collide more with each other. Sure, because they have less space to like move, so they keep hit each other, they keep collide each other. Okay, so also here, can you see it was almost 25, it become almost 70 atmosphere. Okay, so I can change the pressure either by heating or by decreasing the volume or by increasing the number of particles. Okay, this how we can change the pressure. Now I want to see the effect of pressure on state of matter. We saw that by heating, I can change from solid to liquid to gas, and by cooling, I can change from gas back to liquid, back to solid, or even from solid to gas directly, or gas to solid directly. Now I wanted to see the effect of pressure. Let's see if we increase the pressure on it. See, it was solid. Now by increasing the pressure, it become liquid. Okay. Also, I can increase the pressure more. It will be like gas. Okay, so also I can change the state of matter also by pressure. Okay, so let's go back here. Model the state of matter. We are done till relate the change of state of matter to the change in pressure. Okay, here I forgot to add one objective that will add it now. Here the relation between volume and pressure, and the relation between volume and temperature. Let's discuss this, or let's investigate this. Who are the scientists who relate the relation between volume and temperature? Excellent, Charles. That temperature and volume is directly or inversely proportional? Directly. As temperature increase, volume increase. Let's see here, for example, this solid. If you heat it, do the particles will occupy more volume or no? They do. Instead of having only this volume at the beginning, they get bigger and then bigger. Even the gas particles, if this container or have a flexible like a balloon or a ball or the tires, you will find them by heating it more, what happened to the volume? The volume increase. So by increasing temperature, the volume increase. The space where these particles take increase. But he say at constant pressure, which I cannot fix it now because by colliding it's changing and increasing the pressure. But we'll assume that it is at constant pressure. Okay? But what happens if the opposite happen? If the temperature decrease, what do you expect about the volume? About the space that these particles will occupy? It will increase or decrease? By decreasing temperature, see, the volume or space that these particles occupy become less. So if I increase temperature, volume will increase. If I decrease temperature, volume will decrease. Exactly. Okay? This was Charles' law. Let's investigate Boyle's law, which he relates between what and what? Volume and pressure. Volume and pressure. Okay, let's make this one liquid or gas so we can see the effect of pressure. Let's see, he wanted to see between volume and pressure. Okay, now see here the pressure is, it's increasing maximum 12 from 8, 6, okay, less than 10, less than 10. Now let's do that. It's not about temperature. We will try to fix the temperature. At constant temperature, I will decrease the volume. When I decreasing the volume, what happened to the pressure? We said maximum 10. See now how much is that? It reached to 30. So by decreasing volume, make it smaller, what happened to the pressure? Increasing. Excellent. Okay, by decreasing pressure, sorry, by decreasing volume, pressure is increasing. And the opposite. If I increase the volume, what happened to the pressure? See, become less and less and less and less. So they are the pressure decreasing. As I increase volume, pressure decrease. This means that they are opposites. Increasing volume, decreasing pressure. Increasing volume, decreasing pressure. Decreasing volume, increasing pressure. So they are opposite. This say that they are direct or inversely proportional. Exactly, they are inversely proportional. Okay, so now let's check what the objectives we have covered. Volume and temperature, Charles' law, volume and pressure, Boyle's law. Okay, we relate the change in state of matter to pressure, the change in state of matter to the temperature, and also I will rephrase, I'll reframe them by the chart in a while. And we name the processes. Here the energies also we have covered. Okay, let's see here. We will go to lesson 4 where we classify elements to metals, non-metals, and so on, the rest of the objectives.